चलो यहाँ से अच्छा we just left with one we left with two extractions of metals ठीक है so we're gonna try and do both of them लेकिन quick recap के remember we did extraction of these metals were kind of very reactive, not very reactive, but the iron is kind of reactive. It takes years for it to rust, but it does rust. Okay. So iron is never really found in the form of iron. But there was a time when iron was actually found in the form of iron. Ki meteorites from the sky, from other planets, they would fall on the earth. जो early man made tools out of iron, but that iron was actually uh, part of meteorites. They would take that meteorite and they would hammer it. Okay, they would hammer it and turn it into tools. And that tools would last for thousands of years, over generations, because there was no other iron. Okay, so they were very, very valuable. But then in the earth, iron would react and form oxides, and it is reduced with carbon. Carbon is more reactive. So what happens is that carbon is more reactive. So what happens is that if you have an iron compound like iron oxide, normally the air has oxygen, so iron normally it rusts and forms oxide. So there are rocks which are kind of red colored. I showed you last time. And carbon is more reactive, so carbon would steal the oxygens and it will form carbon dioxide, and iron would be produced as a result. The same with zinc as well. Zinc, carbon is more reactive than zinc if you have zinc oxide. So carbon can steal the oxygen and form carbon dioxide, and zinc will be produced as a result. So there's going to be a displacement reaction. So extraction of iron was that most of the ores were iron oxides. Hematite was the most common one, but there were other ones like limonite and magnetite and siderite. But most of them were just iron oxides. You did all the reaction in the blast furnace. What a blast furnace is basically just a furnace where hot air is pumped in. There are three raw materials that are added. There's coke. You can remember these are your three raw materials which are added from the top. So there is coke, which is basically carbon. It's coal. Hematite, which is a rock which contains iron oxide, and then there's limestone that is added. At the bottom, everything catches fire because you're pumping in oxygen. The coke starts to burn, a lot of heat is produced, it's highly exothermic, and the mixture melts, all of it melts. And further up, what happens is that the carbon dioxide produced reacts further with the coke and turns into carbon monoxide. And further up, what happens is that the carbon and carbon monoxide, they start stealing oxygens from iron oxide and they start turning into carbon dioxide, and molten iron is produced as a result. And so this over here is the redox reaction that's happening. And then limestone is added so that you remove acidic impurities like sand. Okay, limestone decomposes, it produces a metal oxide, which is basic, and sand, which is a non-metal oxide. Remember, metal oxides are basic and non-metal oxides are acidic. They react together and they form slag, which is calcium silicate. The other acidic impurities as well, like phosphorus oxides, which would also react with मतलब उसका भी लिख लेते हैं. Calcium oxide can also react with phosphorus oxides, and that would also be part of slag. So it's going to form calcium phosphate. You can balance this equation. So it's going to end up forming अच्छा calcium एक से छोटा कर ले. अच्छा, it's going to end up forming calcium phosphate. That's also possible. Now Now iron is heavy, so as soon as iron gets produced, all of the iron kind of sinks to the bottom of the molten mixture, and it lies right at the bottom, right? So that's where you're going to get the pure molten iron. On top of that, slag floats on top of it. You get all the impurities. This low density slag floats on top of it. ठीक है, low density slag यहाँ पे लिखा हुआ है. So that floats on top of it and is skimmed off. The iron is removed from the bottom. अच्छा, फिर last time what we did was that we did that there was a lot of excess carbon that was present. ठीक है, iron obtained had a lot of excess carbon in it. So iron and carbon was actually what it was, high carbon steel. ठीक है, it was an alloy. And alloys were strong. So what you did was that you had high carbon steel, which was very strong, but not very flexible. That high carbon steel was turned into low carbon steel, which is mild steel. How do you do that? You blow oxygen through the molten iron that you obtain, and carbon in it would react with the oxygen and form carbon dioxide. So that would reduce the amount of carbon that's in there. Okay, so that was the last thing that we did. And mild steel is you make machines and car bodies out of it. Okay, so that you use mild steel, you make mild steel. There's another type of steel which is made that's stainless steel. As a stainless steel is that it has iron, it has carbon, and you add nickel and chromium in it as well. So the good thing about stainless steel is your cutlery, it's your surgical instruments, your scissors, etc., surgical instruments. A lot of your cooking utensils are made out of stainless steel because it doesn't rust. So it does not rust. And it has a very tough chromium oxide layer on top of it, which is pretty shiny as well. So that layer is actually surrounding it. So stainless steel is like, you just have to remember this, because stainless steel has nickel and chromium in it. So that's it. That's the extraction of iron. ठीक है. Am I clear, Hania? The meter, is this clear? Here, is this clear? Stainless steel. So
Yes.
the whole. So now the next thing that we are going to do is, okay, we're going to talk, although zinc is not directly part of your syllabus, but you get questions on that because its extraction is very similar to iron. So we're going to do extraction of zinc, which is short as well. You don't have to go into a lot of detail. That's the extraction of zinc. अब इसमें ये कि normally the zinc ore is zinc blend, which is ZNS. I said, remember, this is not part of your syllabus. I mean, you're not supposed to know this. But because you've done extraction of iron, which is why they give questions where you have to use the same logic that you used in extraction of iron. Okay, this is also going to be reduction with carbon. And the first thing, they might ask you to write the equation yourself. That molten zinc blend is ZNS is burnt in air. And they might ask you to write an equation, which is quite straightforward, that if you burn ZNS in air, what you're going to get is zinc oxide plus sulfur dioxide. And then the next thing is, they might ask you that zinc oxide is extracted in the same way as iron. So what you're going to do next is that ZNO is reduced by heating with carbon. And they might ask you to write an equation. So what is that going to be? It's ZNO plus carbon. Carbon is more reactive than zinc, so what it will do is it will steal the oxidants. It will form carbon dioxide, and zinc metal would be produced. Because you can just balance this, two zincs, to take a balance. And the first one we can balance as well. That's going to be 3/2 O2. Okay, then 3 oxygen on the right side, right? So anyways, you've got both equations, and that's how zinc is produced. The questions that you normally get, zinc also has a very low melting and boiling point. So zinc metal is extracted from the mixture by distillation. The other compounds have very high melting points. This one is simply boiled off, and the vapor of zinc is then collected on the other side, by distillation. The simple is just two lines. That's how zinc gets extracted in exactly the same way as iron. ठीक है, ये clear है? Is this clear about zinc? Siddharth clear है? Yeah. Zainab, is this clear? अच्छा, अब ये कि अच्छा, moving on. Now a totally different one. ठीक है, what about the metals that are even more reactive than अभी हमने कौन से reduction of oxides with carbon, we did that. Now what we're going to do is we're going to talk about the very reactive metals. So I'm just going to copy all of this. So the top ones, the very, very reactive ones. ठीक है, the ones that are even more reactive than carbon. ठीक है, it's up to this point. So they are more reactive than carbon, so they can't be reduced by carbon. So these can't be reduced by carbon. So for example, if I have calcium oxide, carbon will not be able to do anything with this. There's not going to be any reaction. Carbon is not reactive enough. Calcium is more reactive than carbon. So carbon will not be able to steal oxygens away from, and it will not be able to reduce it. So it can't be reduced by carbon, that's one thing. And they can't be reduced by pretty much. And remember, carbon is important because carbon is something that's very cheap. Industrially, you're looking for substances which are very, very cheap. Achha, but the only method left for these is the electrolysis, and not of aqueous solutions, but electrolysis of molten compounds. Because even aqueous solutions would not work. And I'm going to explain why it won't work. You can remember, not aqueous solutions. So that means if I have NaCl, but how do you get sodium? The most common sodium compound is is NaCl. So if I have NaCl and I want to extract Na out of it, so I'm going to do electrolysis, but not of an aqueous solution. I'm going to do it. Okay, I would need a cathode. So here's my anode. Let's make the cathode. Okay, that's my cathode. We're going to have a, so let's say that's a, so we will have a battery. And this is NaCl liquid. So it's only going to have two ions. One is Na+1, which will be attracted to the cathode. This is your negative cathode. And the other one is Cl-1. And that's going to go to your positive anode. Okay, so just two ions. Electrons would come from the cathode, from the negative terminal of the battery, and they would eventually be gained by Na+1. And over here, electrons are going to be, they're going to be lost to the battery. But anyways, we're just focusing on the cathode at the moment. So Na+1 would be the one that will gain electrons. It just needs one electron, and it will turn into sodium metal. So this sodium metal deposit obtained at cathode. Okay, so electrolysis will work, reduction will not work, because you will not be able to displace sodium. Sodium is so reactive. Okay, so electrolysis is going to work, but for that you would need you would need high temperatures. Clear है? Yeah, Zainab, is this clear? Ahmed, is this clear? ठीक है. So you would need very high temperatures. Achha, plus one more thing is that
So say how hard is A-level chem?
क्या?
Like what is the difficulty level of A-levels chemistry?
तो A levels किस क्यों आया ज़हन में?
ऐसे पूछ रहा हूँ वैसे just.
हम्म?
A-levels की
नहीं,
इससे ज़्यादा मुश्किल होगी सर.
ये खुला होता ना A levels किधर था? हाँ ये A levels है. नहीं A levels की obviously मुश्किल है ना, वो ज़्यादा मुश्किल है. ये A levels है. एक सेकंड. ये जिससे है. या छोड़ो. नहीं A levels में सब सारे subjects मुश्किल होते हैं. Not just chemistry. It's a lot of people find the worst subject, the most difficult subject most people find is physics. A levels में. अच्छा कहाँ पे metals? तो ये क्लियर है ये वाला कि अच्छा why would aqueous not work? ठीक है, why would aqueous, because if it's aqueous then there's going to be H plus 1 and there's going to be OH minus 1. So reactivity series में, remember, if you remember electrolysis, that if the electrons come in, they are gained by the one that's less reactive. So the electrons would be gained by H plus 1, not by Na plus 1. So that's why aqueous solutions, the electrolysis of aqueous solutions will not work. Okay, is this clear? The NaCl aqueous will not give you Na. NaCl molten will give you Na. Siddharth, clear है? Sai, is this clear? Yeah, Zainab, is
Yes
this
sir.
clear?
Yes, sir.
Okay, so remember only molten. Now, and this is reduction as well. It's Na plus 1 is reduced at cathode. It gained electrons. Okay, so now what you need to study about this is that you have to study extraction of aluminium in detail. Extraction of aluminium. So this is in detail, and this is done via electrolysis. Yeah, that needs to be completely studied. Which is going to be very similar to what we just did with NaCl. It's in the same group. It's reactive. So only electrolysis would work. And also of molten, remember molten electrolyte. Which again, this is also one of the most favorite big question, which means that it's going to be a 10, 15 mark question. The first thing is the raw material for the extraction. So the raw material is called bauxite, which is aluminium ore. So it's a rock that contains a lot of things. Okay, bauxite is Al2O3, plus it's got rocks in it. It's got lots of other impurities as well, plus other impurities. And those impurities could be iron oxide. You can remember iron and oxygen, their combination is present in almost all rocks. And other metal oxides, etc. So it's got Al2O3, aluminium oxide. So bauxite is the rock, okay, and it's a rock that's probably present in. I said one thing about aluminium is that aluminium is one of the most abundant elements in the Earth's crust. Like if you look at sand, sand has a lot of aluminium oxide. There's a lot of aluminium oxide in sand. So it's very abundant. But okay, bauxite is something that's normally present in your homes as well. It's used as a scrubber. It's a rock which has a lot of pores in it. So bauxite is something like this, and it's used to well, people use it on their feet. It's like a rocket. Yeah, so अक्सर देखा होगा घरों में it's used to even on their hands, like scrubbing your hands, etc. But anyways, bauxite is the ore. Now, step number one for this is, do you remember this is the same electrolysis but in detail? You have to do this in detail. Step number one is purification of this rock, purification of bauxite. So you have to extract alumina out of bauxite, aluminium oxide. Now, bauxite consists of two things. One is Al2O3, and the other thing is it's got impurities. And those impurities are other metal oxides. And the example is iron oxide. I said, how do you extract aluminium oxide? The thing is, aluminium oxide is amphoteric, which means, as remember, amphoteric is a very important word. You need to know what amphoteric is. It's something that reacts. It is capable of reacting with both acids and bases. While other metal oxides are normally basic, which means they react only with acids. Now, what you do is you take these rocks, this bauxite, and you dissolve it in concentrated NaOH, which is the base. And that's obviously a base. So since this one is amphoteric aluminum oxide, it is capable of dissolving in NaOH because it will react with both acids and bases. Other metal oxides will not because they only react with acids. So what happens is your Al2O3, it eventually reacts with NaOH because it's amphoteric. It's capable of reacting with both. It forms a salt which is NaLO2 plus H2O. This is known as sodium aluminate. That's a Fe2O3 and the other the basic oxides, they don't react with NaOH because they only react with acids. So they don't have a reaction. So basically, when you dissolve the bauxite ore or the rock, you just throw the rock in in a container that's got concentrated NaOH, and all your aluminum oxide that's part of the rock that will dissolve, while the other metal oxides they won't dissolve because they're not amphoteric. So Al2O3 is dissolved, while the other metal oxides which are basic are filtered off. Here they're just simply filtered off and removed. So that's how you basically extract aluminum oxide from the rock. Because aluminum oxide is amphoteric, it's capable of reacting with both bases and acids, while other metal oxides, they cannot react with bases. They will only react with acids. So aluminum oxide dissolves in the rock, while the other metal oxides, they don't. And they're just removed and they're just filtered off. And that's how you get pure alumina. This is called alumina. You get this thing over here. Achha, next step, that's how do you get aluminium from aluminium oxide? That we'll do tomorrow, okay? Achha, but these two equations are kind of very important. Plus the logic behind that your rock, how do you get aluminum oxide out of it? You got to remember that, okay? If we will continue with this tomorrow, we'll do the next part, which is once you have aluminum oxide, how do you extract aluminium out of aluminum oxide? That's electrolysis. So we'll do that tomorrow. ठीक है, clear है?
Yes, sir.
तो कल करते हैं, ठीक है? चले, okay everyone.
Laugh as well.
Take care, love.